In the last video, our friend over at DAPS Academy helped us mathematically solve a real-life application question when your dad is coming home.
Never coming home. And there's your final solution.
In this lesson, we will be finding the volume of a bullet in a Nerf gun in order to playfully shoot our dad if he ever so decides to come home. Let's say that we have a Nerf gun here, and we are trying to find the optimal volume of a bullet that fits our Nerf gun. Let's say that we are given that the length of the barrel is 1 inch. And from this, we can draw a graph and assume that the top half of the bullet looks something similar to this kind of a shape. And conveniently enough, this takes the shape of the equation y equals square root of x. Y equals square root of x. So we know that in order to find the volume of a solid, we are taking a 2D area and rotating it around a line of axis. In this case, we have the top half of our imaginary bullet, and since we are trying to find the volume of the bullet, we need to use the disk method and rotate it around the x-axis. Since the length of our barrel is 1 inch, we will start at the origin and end at x equals 1. Now, how do we go from getting a 2D figure and turning it into a 3D shape in order to find the volume? Well, as of now, we only have the top half of our bullet, and in order to see the whole bullet come into shape, you can reflect it over the x-axis, and we can start to see the entire thing on our 2D plane. Using this, we can find the volume, and to do this, we will have to think of the bullet with cross-sections of infinite disks. We sum up the volume of each individual disk, but before we do that though, we will look at each individual circle to see how this works. The area of a circle is pi r squared, where the radius r of x is the shaded area, which in this case turns out to be square root of x. In order to find the area of the radius, we have to subtract the top curve from the bottom curve, which ends up requiring us to solve the equation, the square root of x minus 0. And I encourage you to pause the video to try to find the answer on your own first. So I assume that you've had a go at it, and we know the area of the radius is square root of x. This is just the area though. To find volume, we do the area times the depth. The depth is the change in x, or in other words, dx. We do this because this is one of the volumes of the circle, but more so because I am Asian, so I make the math rules. Eventually, we will have an infinite amount of these individual disks, so we can grasp a more accurate number for our volume, and we'll use an integral with the limit of integration being from 0 to 1. To make solving this integral simpler, we will move the pi out because it is a constant. Then, we can simply solve for this equation, or can plug it into a calculator because I am lazy, and we'll end up with a volume of pi over 2 inches.